So just to reiterate, apologies from Claire. She had some bad news last night, so I had to fly back first thing this morning. So what I'm going to be talking about here is very much the academic perspective on storage at the moment, and particularly from UCL's point of view. And it's not about solving a very specific problem for a particular workflow, a particular experiment. It's about a more generic initiative that UCL's undertaken, and why we've chosen what we've chosen, and where we've got to so far. So, first of all, apologies again, because these aren't my slides, and I'm learning about this at the same time you are, so I'm sort of reading this as we go along. So, UCL calls itself London's global university, so ranks in the top 10, blah, 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 as you can see. So the origin of UCL is that it was set up as an inherently secular institution at a time when most universities were generally connected with religious institutions of one sort or another, and it was therefore called the Godless Institution of Gower Street, which is where it's based in London. Interestingly, when it was set up, George IV, who was king at the time, set up King's College London in response to it, which is inherently linked in with the Church of England. So, and I have a bit of mixed feelings about this because I was at medical school there, so I'm slightly cross from one side to the other. So it's grown significantly over the last 10 to 15 years, mostly through mergers. So the University of London has been collegiate for a long time and has seen some consolidation recently, so it's grown quite a lot. And in the UK, it's one of the measures of universities' performance is the REF, the Research Excellence Framework, and universities submit different modules to the REF, and only Oxford submits more in the UK, so it's very much a multidisciplinary organisation, and that's actually quite relevant to why some of the choices we've made in the Research Data Initiative. Make sure these are allowed.
It's a stupid question.
Go on.
These alumni are women?
No, that's probably just a Latin mistake.
Okay. you point out the woman, so it might have been.
Or maybe it is, sorry, I don't know. Where is it?
Yeah, in the second line.
Potentially, I'm not sure. Okay. So UCL's had a number of sort of large initiatives. UCL Grand Challenges, which was launched a few years ago to focus projects around global health, sustainable cities, intercultural interaction and human well-being. And that's been very successful for a number of years. And there's a new initiative recently started called UCL Research Frontiers. And that's very much involved in subjects that are inherently cross-disciplinary, and it has fed into a whole area of activity that looks to provide services to underpin these cross-disciplinary activities. So in June 2012, Research IT Services was created. This is the department I work for. It's not tied to a particular research area. It's part of the central IT services, and it's really aiming to take away some of the burden of running IT systems from different departments, and at the same time act as an enabler for cross-disciplinary research. So I think we've got some, that's what's going on, little pop-ups. So looking at these on here, how does this work? Yeah, so IRIS and RPS represent the, so IRIS is a grant application system, and RPS is a publication system. But the other two, the collaborative tools and development of research itself, and then finally the exploitation of research, both of those, as you see, involve research data inherently. So this is where it's created, and this is part of the ongoing initiative, this is going to be where we exploit research data for the good of further research. So this is about just the general goals of this department, I guess. Let's just skip over that. Okay. So this is my slides now, so I'm happy here. So what was UCL's case for creating this research data initiative? So in addition to all of the things I've discussed already, there are many departments, many departments and research groups that have been around for a long time. And there was the recognition that at the moment, or up to now, a group could have produced a lot of research and data would be somewhere, but no one knew exactly where, not necessarily managed. And a new student or a new research could come along and wouldn't necessarily be able to take advantage of that existing data. So this is a real lost opportunity for new research building on old. UCL's highly multidisciplinary, as I've said before, and if you have storage provided on the basis of research projects, you lose the opportunity to reuse that data or those data sets in other disciplines, and you don't take advantage of that inherent cross-disciplinary, multidisciplinary nature. And then finally, this issue that unmanaged data sets are effectively lost data sets. Even within an ongoing project, there's an increasing burden for researchers because they're beginning to realise that as a lot of effort has been put into producing data sets, unless they're managed, they can easily be lost. I was just speaking last week to somebody in the anthropology department who's spending an awful lot of his time running backups and trying to keep track of which backup disk is which, and the entire system is based on a NAS device that he's bought from PC World, one of the sort of general electronics stores around the corner. It's just not a scalable solution. He's beginning to get a bit panicky about it because a lot of this data is very valuable, and not necessarily just in monetary terms, but in how difficult it is to produce it. And so if we can do something to prevent him having to do all of that, that will be of real benefit to his research. Okay, so difficulty is, it's all carrots, no sticks is all we can do really here. Researchers are independent beasts. They do what they want. Research data is an offering. We aren't telling them to use it. We can't tell them to use it. They will use it if they want to, if they find it useful. They will opt out. Some people will simply say, actually my particular area of research is so specific, I can do this better. And they're right. We shouldn't be cross with them for that. So this has been the sort of core thing. We're trying to remove the burden of managing storage, and we therefore need to identify these burdens and offer this service that removes that burden, those burdens, and hope that it's something useful to researchers. Something that's quite interesting, that just speaking with different groups, they're often very concerned about backup and managing backup. And they've been quite interested when we suggest to them that we actually don't really want to give you backup, we want to give you resiliency. So we don't talk about backup, we talk about resilient systems and disaster recovery systems. And this is a bit of an eye-opener to them because it's an approach that they can't do themselves. They can't get the hardware for that. They haven't got the time for that. And then finally, there's this issue of the research councils in the UK. These are the bodies that fund research, are beginning to make noises about data management policies and encourage people who receive funding to be compliant with these sort of nascent policies. So in fact, there is a little bit of a stick here, but in fact we don't really want to push this very much because personally I don't think that the researchers have any more respect for the research council than they have for us, so they'll just ignore them anyway. And there's very little the research councils can do about it if they just choose to ignore them. So we went through a period of requirements capture, and we asked the researchers what they wanted. The problem is they want everything. So it sounds a bit like a Yahoo type statement, doesn't it? But with all the exclamation marks. They want everything they've got, more of it, faster, shinier, the whole lot. It was interesting that these were the sorts of NFS, SIFs, these were the sorts of activities that were generally available, departmental provision. Things like SCP and Grid FTP were available in, so the physics department, in more sort of project specific areas. And then this thing that no one wants to talk about, everyone's using Dropbox unofficially, basically.
Yeah.
The institution had some requirements as well. Fortunately, they're not massively compatible, but they want a very low admin overhead. So we're a team of 4 people, including the people that sort of do all the management side of things and work with the funders internally to make sure we keep going. So we're not a big team. Cost per terabyte is a very interesting but very irritating indicator as far as I'm concerned, because some people are overly concerned about it and fail to see that lots of terabytes are not much use if you can't present them in a useful way. And high density, we're in the middle of central London, and data centre space is very, very expensive. So we need to consider that. So architecture choices. Bearing in mind all of those requirements, we decided we were going to start with something that was simple, tried and trusted. So, what are people using at the moment? If they're already using it, that means it's useful for them. We wanted to avoid this, what we call the big data hysteria. So, it's very easy for people to look around and see the world's changing, all sorts of completely radically new ways of talking about data management. You know, we had, when we went to tender for this, we had proposals ranging from sort of conventional HSM solutions, which were probably a little bit too old school, to content management systems for everything, which seems, you know, that's not going to work either. And then somebody even suggested we do the whole thing in SharePoint, but anyway, that didn't go very well. We wanted to work with strong abstractions. So whilst we do have a solution, I wouldn't be here otherwise, based on DDN technology, we're a university. We can't afford to be locked in to something that is potentially going to cost a fortune in the long run and may not be the best thing in, who knows, 5 years, 10 years. So we needed these abstractions to provide us with an escape route, if you like. And with that in mind, we wanted to hedge our bets. So in the architecture that we're implementing at the moment, we've built in migration between the different types of storage that we've bought. And this is slightly different, but in the way that we consider storage, we made the decision that we'd be project-based rather than user-based, rather than department-based. So the idea being that all research activity is inherently funded in some way by something that can be called a project. And projects are generally time-limited, and you have possibilities for starting the project and working with people, finishing the project, working with people. It's a convenient way of managing how we provide access to storage. We made the decision to have 2 separate concepts of type of storage areas. So we have live and archive. So what we mean by this is that the live area is the live project. So when the project is ongoing, this is a little bit like what people might be doing at the moment in terms of their existing disks or whatever they're using. It's mutable. It's what they need at the moment, and it's essentially private. They do what they want there. We allocate an area of live storage, and then it's up to them what they do. We're not going to dictate anything about that area. And this is essentially what we've tackled so far. But we've tackled that whilst bearing in mind that in the long run, we also need to provide an archive area. And that if we manage this bit properly, it can feed into that in a much more effective way than we would be able to create an archive from scratch. So the core features of the archive area are that the data that's there becomes immutable. Exploitable is a horrible word, I think, and researchers generally don't like it. But this is taking into account the realistic requirements of a particular data set. So exploitable is certainly not the phrase we'd use if we're talking about patient identifiable data, for example. But you know, depending on what the data is, there's a general principle that we want to make it as easy as possible for other researchers to take advantage of those data. And that's not necessarily just within UCL, that's much bigger than that. And then core to our service is the idea of a transfer of responsibility. So whilst this is a private area, the live area, it's up to them what they do. Once the archive has started, we essentially look after that data. We're responsible for it at that point. The researcher may have left UCL by then, and so we need to put into place lots of processes to manage how we look after that. And there's an ongoing UCL-wide project to come up with a series of statements about how data is managed. So, I have no idea why I've got a picture of a gear stick here, but it says metadata on it, and it seemed the right size. So metadata, so this is one of these words that gets bandied around, and people don't necessarily see the point of it until they need it. No one wants to put metadata into things, so you've got to tackle it in a sort of slightly underhand way. And we use the separation of the live and the archive area, or we will use the archive area. So this registration process is what's needed to get access to live storage. And it can't be too onerous, so we collect a very small number of simple pieces of metadata. And you might think, well, that's not achieving very much, is it? But actually it's compared with nothing, that's an enormous amount. At the moment, we don't have any idea. You know, you may just wander into a lab and there are USB hard drives there. No one knows what's on them at all. At least with this relatively small set that everyone can provide without much difficulty, we have a massive advantage over our current situation. And then when the data set goes into the archive phase, this bit is very much proof of concept at the moment, but we will be working with the researchers to find a sensible way of allowing them to enrich the data that they're storing in the archive with further metadata, but that's often going to be domain specific, so we don't want to mandate what that will be, and this is going to be a sort of watch this space situation. So where does that go? All that metadata. Well, we've made the decision to work with iRods, which I don't know how many people here have come across iRods. Yeah, so a few hands. So it's been around for a long time. It was the storage resource broker, 7 or 8 years ago, and it's sort of an evolved middleware layer that, in its simplest form, you can say it was a metadata store. It's the ICAT database which holds metadata. But it's a lot more than that, really, because that metadata includes file-specific metadata, so where particular files live, the sort of access control, all that sort of thing, groups, all the usual POSIX-type metadata. But you can add arbitrary metadata as well. And it's an abstraction layer that lets you use lots of different storage types. So back to the comment I made earlier about wanting to hedge our bets, not wanting to be tied in. By using iRods, we have a built-in bridge between different areas of storage. So we can be confident that as long as the different types of storage that we've provisioned so far can all be spoken to via iRods, we have a way of migrating files from one to another. And so these are some of the types of storage, so conventional storage, object storage, and tape. We haven't done anything with tape yet, but it's an option that's there. The other nice thing about iRods is that depending on how you use it, you could actually expose it to the users during the live phase of a project, in which case they would be able to add metadata as they go along. That's not something we've done so far because, to my mind at least, probably the weakest component of iRods is the user-facing, the user interfaces. I'm not happy with the average user being able to use them properly at the moment, but it's something that we're going to consider, and very much certain projects would probably benefit from that, and we'll be hoping to expose those interfaces to them. So finally getting to some DDN stuff. So we have some WAS, which we've been very pleased with, I have to say. So the reason that we ended up going with WAS was its simplicity. Back to strong abstractions, very clearly defined things. WAS is just an object, so I think James called it a sort of just a bit bucket. But that's good. It means it's not trying to do anything else. It's not trying to provide everything to everybody and then ending up becoming incredibly inefficient because it's doing that. There's WASLib, but we mostly think about it in terms of the REST API. It has concept of policies, so you set the number of replicas you want. You can set whether you want geographical redundancy, so that means putting on a different physical box. One of the copies has to be on a physical box. You can join nodes to a WAS cluster from all over the place without much difficulty. So we've currently got 2 WAS boxes, physical boxes, so that's 4 nodes altogether. But as a bit of a test, because we're nowhere near full capacity with any of our storage at the moment, as a bit of a test, we've taken one of those nodes out of the cluster and we've paired it with a similar setup at the University of Oxford. And it was a bit sort of difficult to get our head around how that would all work to start with, but actually when we did it was easy. And the way it happily will replicate across to the other site, it all just seems to do what it says on the box, basically, and we're quite pleased with that. James mentioned all sorts of developments possibly coming around WASBridge and these different ways of making greater use of that sort of thing, but we aren't doing that at the moment, but we're very much interested in those developments as they come along. One of the main reasons that we like this geographical redundancy actually is that for universities there's an advantage in that you can make use of each other's data center facilities and get some redundancy at the same time. So you have an off-site copy that you don't pay for because your off-site copy is someone else's primary copy and their off-site copy is your primary copy, and it's a sort of nice mutually beneficial situation. So we're reliably informed that there are deployments of greater than 10 petabytes. I suspect it's quite a bit bigger than that, but I know there are some secret WASs around. As I say, low admin overhead, there's very little to set, so nothing much to administer. And quite important, there's a native iRods connector. So iRods has the concept of vaults, of different types of storage, and there is one that's natively supporting iRods, and so the object ID for the object that goes into iRods gets stored in the ICAT database, and that integrates nicely with iRods. So another component that makes use of WAS directly is WAS Access that we're using. So this is essentially a NAS presentation of WAS, as James mentioned before. So we have people who want CIFS and NFS, and this lets us provide it to them. We have an HA set up, and it's quite nicely backed up into WAS. So one of the things I liked most about WAS Access when we started exploring it is that it's all very open. It's based on open source projects and quite easy to you can peer around inside and see what it's doing. I don't think I'm breaking any NDAs here because no one told me this. I just explored myself, and it's just a Postgres database holding object IDs. So RabbitMQ is used to synchronize the databases. I mean, within an hour or so of the first time we were playing with was Access, I'd written a little Node.js app that allowed you to grab objects out of WAS by putting a file path into a URL. So it's comfortable to have something that's providing useful functionality, but it's open enough that I don't feel like we've bought some big black box that we don't know what's going on inside. And then even the backup side of WAS Access is quite nice as well, because it's just quite simple. So the database gets backed up into WAS as an object, and it emails you telling you it's been backed up, and this is the object ID. So if the worst came to the worst, you could essentially lose the entire WAS Access infrastructure, just use a wget to pull the object out of WAS, reconstruct the Postgres database on a totally bog standard Postgres, and then find the object IDs of all of the files you've got stored in WAS. So it's just sort of nice and flexible. So we also bought some GPFS. This was because there are projects that want high performance storage, and we didn't really know quite how performant WAS was going to be. So I know there's lots of material showing that it's very competitive in the object store space, but we wanted to be sure that we were meeting the specific requirements of people that have the HPC users that want just conventional POSIX file systems with high performance. This allows us to share our live area with UCL's existing HPC resources. So the main Claire, who would have been here, runs the Legion service, which is a cluster service, a compute service, and they run Lustre as their scratch space, but they're also interested in GPFS, and so we're going to be starting a little collaboration with them and also with other HPC resources within UCL, whereby they multi-cluster with our GPFS, and it's a sort of parallel activity in many ways, but at the same time it's meeting the very real requirements for those HPC type users. It's not been without its problems, actually, more so than WAS in many ways. So you can sort of export from GPFS in many ways, but they don't necessarily work particularly well together, we found. So there are issues around locking. In the end, we've basically had most people using SCP, and interestingly that's fine for them, but it does slightly beg the question why you need a massively high performance file system if SCP is fast enough to talk to it. But anyway, that's another debate. That's probably not, that won't be the case surely. When we've got native GPFS to the other clusters, then we will be using it, no doubt. But so cloud, so that's probably a silly thing to say in the general context of storage that dare not speak its name, but in universities it's sort of true, because well, certainly UCL hasn't provided anything in this space, and we don't approve of Dropbox and SugarSync and blah blah blah, but they're being used by everyone, so it's something that we had to tackle, very real requirement. Something that's slightly unfortunate is it is evolving so rapidly. I mean, I've been of necessity keeping track of each new initiative in this space, and there seems to be one every other week. And there's not necessarily that much innovation. It's just another version of something that's slightly different and always incompatible. And it would be really nice to see some standards evolve in this space. And that's got to happen on the clients as well as on the server. So if Apple and Microsoft and somebody will then implement a Linux version agree on a standard way of mounting this sort of asynchronous storage and talking to it. So we have something in this space in our sort of pilot phase. So Oxygen Cloud, which some people may have come across. The reason we went with them is that they allow you to use your own storage. So that I think what's the phrase now? Private cloud is the thing that's coming in. But you run a connector in front of your own storage, and when your client application starts, it gets redirected by their central server back to your storage, back to your authentication. And then fundamentally important, actually, and this is the one thing that I don't know of any other cloud service that does, is everything's presented on your desktop, on your laptop, but as stubs in the first instance. So you can have a couple of 100 terabytes of storage presented as stubs, and then when you double click on them, they start to synchronize. So where are we at the moment? We're still in very early days, as you can see. So I mean, we've got altogether about half a petabyte of usable storage, but we're only using 35 terabytes at the moment. We've got 11 projects, 22 users, so it's very early days. And at the moment, we've been focusing on choosing that bit of our existing infrastructure that best meets the requirements of a particular project, and then allowing their experiences with that particular interface to inform how we work going forward. So we're continuing to deploy and slowly expand the number of users. I'm a bit short on time here. I'm okay for 5 minutes or so. Yeah.
I have a question. How are you mounting the Oxygen Cloud on WAS?
Totally in an unsupported way. We basically just do a WAS access export of CIFS.
Oh.
So it works. And the nice thing about it, that's actually quite interesting, because the way Oxygen Cloud deals with local storage. Because it's originally designed as a cloud product, it encrypts everything, which is actually not what we want at all. We quite like the files to go directly into WAS, but it actually encrypts them and it chunks them, so they go in relatively small chunks encrypted. So at the moment, the only way to get something from Oxygen Cloud into another type of storage is to pull it out through Oxygen Cloud and put it back in again, which is less than ideal, but it certainly isn't breaking WAS access. So this is possibly an overly complicated diagram, especially for people at the back, but it's just meant to give you a bit of an overview of how things are so far. So we've got all the storage over here. So we've got most of the storage is 12K with exposed via GPFS, via grid scaler, and then we've got a smaller bit of WAS. And I've sort of included WAS access in that blob there. So the principal investigator of a project comes along, they go through our registration process, which is currently manual, give us those bits of information, metadata. We store that metadata into ICAT, so we use iROD straight away as a way of holding that project-related metadata. We create a project group that goes into AD at the moment. This Moonshot is an activity that I don't know whether anybody here is aware of, but it's EduRoam, which is available here for wireless, allows federated access to networks. Moonshot is a way of taking the same technologies, basically radius, and exposing that to application space. And we're piloting building on Moonshot to provide access storage. So those get created, the metadata stored, and then an email goes to the user, one with details of how to access via Oxygen Cloud, that goes in via the storage connector and the authentication connector, and the other that provides details of how to access via the other mechanisms, so primarily SCP at the moment, but CIFS and CIFS and NFS too. And yeah, that's basically it. So the double arrows are all more than 10 gig networks, so reasonably high performance. And then at the back end, we haven't done this bit yet. So we do need to cater for the disaster recovery situation. And so we're going to be making use of iROD's policies to store probably onto tape. We work quite closely with the computer science department at UCL, and they've just bought a big tape library, or not a big, a tape library, and we're thinking of using that with iRODs, but that doesn't exist at the moment. So particular challenges we faced so far, well, as I mentioned, Moonshot then. So a lot of projects want to go beyond UCL straight away. And the existing authentication systems just aren't set up for this at all, certainly not at UCL. So we've struggled a bit with this, particularly because the people that run Active Directory don't really buy into it. I mean, their primary concern is standard UCL undergraduate users. They don't really see the problem. So this has been a real challenge for us. But as I say, we're a pilot on this Moonshot initiative, and we'll see where that goes in the next few months. Networking has been a problem too. So you might think universities are reasonably well networked, but part of the difficulty is if you've got a little research group with their own NAS device, their own network which is entirely under their own control is the only bottleneck they see. If we're providing central storage, you suddenly reveal a whole pile of really weak links around the campus, around the university network. So we've ended up having to spend money on putting in some new switching to upgrade the networks of the pilot users. The multiple access mechanisms, what I'm getting at here is that I've talked about different types of storage, different ways storage is presented. What we really want is a common view across all storage, so a way of joining it all together. That doesn't exist at the moment. The closest you can get to it is the iRODS view, but as I say, I don't think that's ready to be the primary method of exposure for end users. So yeah, probably going back to the hysteria around big data, we somehow managed to get into the Evening Standard a few weeks ago, the London Evening Standard's the free newspaper in London, about this helping UCL research with blue sky thinking. I think there's a bit of a UK specific weathery joke thing going on here, but obviously it's a topic that's catching people's imagination, so we're quite happy with where we are so far. Thank you very much. Any questions?